Okay, good morning, class. So, as you guys agree that the work was just way too little for you guys for this lesson for today, so we're going to do the examples for exercise 12.2. Okay. So we spoke in our previous lesson about mutually exclusive events. So the probability of A or B is equal to probability of A plus probability of B. And then for events that are not mutually exclusive, which means to say there's an overlap, we use the formula, the probability of A or B is equal to the probability of A plus the probability of B minus the intersection of A and B. We're looking at the examples for exercise 12.2, and this is on page 400. Which page is exercise 12.21? Sorry? 401. And the example starts from page? Sorry? 400. Where is that here? So the complementary rule, we spoke about this on last year as well. And earlier on we also mentioned it, that the probability of A plus the probability of not A, okay, probability of not A will always be 1. Okay, so the chance or the chance that the event can happen and the probability that the probability that the event can happen opposed to the probability that the event cannot happen must always add up to 1. Okay, so that's a complementary rule. It's very important. Okay, fundamental rules, no? The probability. If two events are mutually exclusive, which means to say there's no overlap. Okay, if two events are mutually exclusive and if together they have a probability of 1, they are complementary to each other. For example, the probability of drawing a 4 from a pack of cards is 1 out of 13. Or 4, there's 4 4s in a pack of cards. Not so. Just go back here. As you can see here, there are 4 4s here. Okay. So 4 out of 52. And the probability of not drawing a 4 is all the other numbers, not so. So it's going to be 48 out of 52. Which means to say, the probability of drawing a 4 plus the probability of not drawing a 4 will always be equal to 1. And these events are said to be complementary. Okay. Thus the probability for not drawing a 4 is complementary to the probability of drawing a 4. So that you'll see here, this dash here on top means to say not. Okay, sometimes you'll see me write it like this. The probability of A plus the probability of not A is equal to 1. Okay, we have to put that thing on the top. It means to say not. It's the same thing. Okay. So I see they put it on the 4 and not on the outside of the bracket. It's probably the same thing to me. So the probability of not 4 is equal to 1 minus the probability of 4, which is 1 minus, which is 12 over 43. But earlier on I said it was 48 out of 52. In simplified terms is to 12 over 30. Okay, as you can see, we write this general rule as the probability of not A is equal to 1 minus the probability of A. I wrote it as the probability of not A plus the probability of A is 1. The same thing. Okay. Calculating probability from the Venn diagram. So in exercise 12.2, here you are just shading. Okay, so let's just go through some rules here. We have done Venn diagrams in grade 10. You guys remember? Right, it was our favorite, no? A Venn diagram is particularly useful when events are not mutually exclusive. So they are mutually inclusive. Okay, not so. Which means to say there's a overlap. So there's sets that belong, these values or elements, that belongs to set A, and these elements or common elements that belongs to set B. And those common elements will go in the middle as it's shaded here. Can you see that, people? Alright. If events are not mutually exclusive, then the two circles will overlap. The shaded area where the circles overlap represents the events of A and B taking place at the same time. This is also sometimes written as, okay, I wrote it like that already, A intersection B, which is called A intersection B. See figure 1. That's this figure here. Okay. Then we are told that belongs to the still. For example, the sample space is drawing a number card from a normal pack of playing cards, from which the picture cards has been removed. So all the picture cards are removed. The event A is drawing a number, and event B is drawing a prime number. A intersection B will be drawing the number 2, which is both prime number and an even number. You all okay with that, people? Alright. Then we are told that the event of A or B taking place encompasses everything in circle A together with everything in circle B. Okay? A or B is represented by the shade A or B. Can you see? It says or. So A or B is everything there. Okay? So that all of that is A or B. If it says A intersection B, then it's only this part here. You guys understand? It's only this here, A intersection B. If it says A union B, then it's going to be all of that. So O is everything, encompasses everything, and is where it overlaps. You guys okay with that? Alright? Just stop me now when I'm moving too fast. We don't understand. Okay. So we will be reading now. Everything in circle B. A or B is represented by the shaded area in the diagram. See figure 2. It is sometimes written as A union B and called A union B. That is all. In the previous example, A or B would be drawing any number that is even or a prime number. Okay. I.e., you got this here. Okay. Just check it something with me. Any number that is even or prime. Okay. Okay. Let's look at figure 3. A complement denoted by A dash means not A. Okay. This will include everything in the sample space but exclude A. Okay. The shaded area in the diagram, see figure 3, illustrates A dash, which is everything outside circle A. In the example, you would be drawing any number that is not even. Okay, so if A was even, all the even numbers would be form part of set A. So if it says not A, it's everything other than A. Even this on the outside of B. Whatever's on the outside of B, which doesn't conform with the restriction on A or B. Everything outside that would also be part of not A. Does it make sense, people? So say for argument's sake you have this here. They ask you to list. You got A, you got 2, 3, 4, 5. You got those elements. Okay, for A, in set A we got 2 and 3. In set B we got 3 and 4. In the sample space, what do we have? We got 2, 3, 4 and 5. Why? Because all of that is in the sample space. Not so? You all understand now, no? Why 5, why 2, 3 and 4 is part. We're still within the sample space. So if they ask you to list the probability of not A, not the probability, but you must list not A. What would that be? 4 and 5. Why? Because that is everything other than A. Make sense now? What if they say list A? What would A be? 2 and 3. What if they say list the probability of A or B? Sorry? No, not the probability, no? Just list. What would that be? A or B? 2, 3, 4. Can you see that? What if you say list A and B? What would that be? 3. List the sample space. 2, 3, 4, 5. List not B. 2 and 5. Can you see that, people? Now just with that in mind, what is, if I must say B plus not B, must list that. B and not B. B plus not B. Just to list what was B? B was? That didn't list B, no? What is B? 3 and 4. Why? Because it all belongs to B, no? So, if I must list B and not B together now, what is this? B, 3 and 4, not B, 2 and 5. But what do we notice now? We have 3, we have the sample space, we have 2, we have 3, we have 4, and we have 5. Can you see? So they clearly you can see that B and not B are complementary. They always add up to the sample space. Okay. But if I had gone with the probability calculation here, then that would have been 2 out of 4, which is of the probability of not B, which would also be an half. And what's a half plus a half? 1. And that's what I said earlier on. What did I say? That the B and not B will be complementary. You guys understand? Alright. Tell me we're not talking too much. No? So let's read what they're saying here. Or they use this example here now. Okay. So here we are told, let's just take this off here. In figure 4, A and B is equal A and B, or can be written as A intersection B. So where do they overlap? They overlap here. And A intersection B is 2. Can you see that, people? Alright. Then it says A or B. So A or B, we see there's going to be all of this. Not so. So it's going to be 2, 3, 4, 5, 6, 7, 8, 10. All of that belongs to A or B. Then it say the complement of A. So it's if the complement of A. That means to say, I'm just taking out whatever belongs to set A. So this is omitted. Okay, and that's why we're considering 3, 5, 7 and 9. Do you see that, people? And what is 3, 5, 7 and 9 plus everything in A will belong to the sample space, which means to say again they are complementary. Okay, you guys understand? So with that you should be able to do exercise 12.2 on page 401. Okay. The full lesson can be found in the description box below. Okay.